Okay, so today we are going to be working on making your own musical keyboard. And we're going to be using 6 notes, an Arduino Uno R3, I believe, 3 long chords, 1 red, 1 blue, and 1 green Arduino chords. These are the ones that are square. 1 black chord, 6 colored chords to match the buttons, and then 7 chords that are the short ones. A breadboard, 6 100 ohm resistors, 3 330 resistors, and 1 RGB LED, and a buzzer. If you were to replace the buzzer with a speaker, I believe you might need a lot more chords. But for this demonstration, we're just going to be using a buzzer. Had we used a speaker, this would have been quantified as a synthesizer because we could make it make different sounds. Unfortunately, we don't have that, so musical keyboard is what we got. Now, we will transition to the building.
All right, let's get into the building part of this demonstration. We will start by first wiring up the main circuit of the Arduino. So we will take our red and blue cords, and we will start by working on the ground cord. So the ground cord is plugged into the ground on the Arduino. Out here, so that it says ground. Around here, and that will be the ground pin on the Arduino. And then from the ground pin on the Arduino, you will plug it into the ground rail on the breadboard. Now, let's start by first explaining how the breadboard works. There will be these different rows, lettered A through J. Each row is a section. There will also be numbers that will number 1 through 16. But in total, there are 64 different columns. Each column is connected. And each row from each 5 dots from the top to bottom are a row or a column. And each column is connected to itself. And so if I put 1 on row A, column 3, anywhere on column 3 from rows A through E will get the same signal. And each rail goes from numbers 1 all the way to 60. And each row is colored from red and blue. The blue being the ground, and the red being the power, which we will do 5 volts. And so we will plug that into the 5-volt pin. Next, we will take our 5 volts and we will plug it into the thread rail. Now we have a circuit. And what we will do is start with wiring up a single button. And so we will take our green button and we will connect it like it just along the center. There's a little well, a little trench in the middle of the breadboard. That will be what we will consider as the break. And the break disconnects the top rows from the bottom rows. So That means that whenever I mentioned earlier about the rows A through E, rows F through J have that same factor. And so any row from row F to J on column 3 will do the exact same thing. They will all be connected and get the same power. Now, how a button works is it takes a diagonal. So we have these 3 terminals, or the 4 terminals. And so we have 2 on one side and 2 on the other. So terminal 1 on side 2 connects to terminal 2 on side 1. And it's vice versa. So you would take a diagonal from each different terminal. And then that's how they connect. So we push it down, but it doesn't matter if you're pressing hard when you push down to put the button on, because it's still going to work. Now, what we will do is we will take one of our 100 ohm resistors, and we will take it and go to the left side, take it and plug it into the ground and into the row that is connected to the terminal. Then we will take one of our short wires from the large pile. Doesn't matter what color, but these will matter what color they are. Although the wire doesn't matter. We're just using the colors for this one as a sort of sorting, so we can tell what cord is what when we plug it into the Arduino. This doesn't matter because it's being plugged in on the breadboard. So we will take it on the other side, and we will plug it into the red rail. Now, we've created another circuit, except it's unfinished now because this button needs to be pushed in order for it to go. Next, what we will do is we will take one of the green wires, and this green wire right here will plug into the diagonal of this other wire. And so when we have terminal 2 on side 1, it will connect to terminal 1 on side 2. This will be plugged into the Arduino. So we will have to move the Arduino over to here, and let's move it here since the button's plugged into the analog ports. This will be our analog 0, and we will refer to it as button 0. We refer to it as button 0 because with computers, variables in a list start with 0 instead of 1. I don't know why. I could probably tell you if I looked it up, but I haven't. So we will address that later, I guess. Maybe. Who knows? Next, this, we'll take our battery, and as a demonstration, I've already put the code on it, but I will show us how to do the code later. Let's turn the Arduino on. Now it's on. Hang on. We won't do this because I would have to have the buzzer plugged in, and we don't have that yet. So I will cut this out later and not do it. There. So we've done this with one button. Now we have to do it with all the other 5s. And I have these in order already because later we're going to be hooking up this RGB. This RGB LED will correspond to what color the buttons are. And I'll get into detail on how these work later. But for now, we're going to put the buttons in with their correct cap quarters. Next is the white button. From the green, we have the white button. Next is the yellow button. Then the red. Then the blue. And then lastly, our second green, which will be our high green. So this is our low green, and this is our high green. That means that the note will go from C5 all the way to F5. So now that we have the buttons put on, we will move to the next part, which will be wiring the buttons. And so, again, it doesn't matter exactly what we need for the color of the wire for the ones that are on the breadboard. But the Arduino's cords over here are colored correctly. And those, we will get to those here in a second. Until then, we are going to wire these all exactly the same that we have already. Starting with 100 ohm resistors. All right. Now we have our buttons plugged up. We have the multiple circuits here. And then, now we're going to plug them into the Arduino. Okay. So, we did our green. Next is the white one. And so we will white wire this. This will be our analog 1. And remember to go diagonally to the color, to the wire that you've already made. Next is the yellow wire. There's the red. And the blue. And lastly, the green. Okay, now we have our buttons wired to the Arduino. Next, this wouldn't be a synthesizer if we didn't have the buzzer. So now we're going to wire up our buzzer. Now the buzzer is special in that he's not going to get an analog, but instead he's going to get a digital cord. And so this will plug into one of the digital ports. And we're going to make sure to place his little pins on separate columns. So he will plug into digital pin 5. You can tell us the digital pin because it doesn't have an A in front of it like the buttons do. And now we don't do much other than now take wait, shoot, I had that plugging into the wrong one. Wait, no, yeah, I just have it plugging into the right one. Okay, so on the buzzer, there's a little plus, and the plus shows which way you want the circuit to run through. So the negative will run from the minus it's like here on a battery. So, on the battery, we have a positive and a negative. So the negative, this is the positive, and this is the negative. So it will flow from the negative and then towards the positive, which means that whenever we have the cords plugged in to the buzzer, you have to make sure that we plug the cords into the positive so that the negative flows towards the positive like a magnet and out of the negative. And so, let me get this plugged back up. So, what we'll do is we will take our last final short cord and we will plug it into the negative pin on the Arduino, or on the breadboard, and then plug it into the ground rail on the breadboard. And now that we have that put in, this should work just fine. Now, this one being the low part, this one being the high part. See? Now, I do have added, we could be done right now. And this can be, it is entirely possible that we could just finish right now. But for I wanted to have a little RGB LED. What this guy does is he has 4 different pins. One for each of the colors and a ground pin. That ground pin being the longer one. And the 3 shorter ones being the colored pins. So, we will plug him in over here on this side. Make sure that each one of the pins goes into a separate column, like we did with this guy. So, now, you will take the ground, and we will do that first. This is going to be our black wire. Again, the color of the wire doesn't matter. It's only how we use the wire. So this will be our ground wire. And this will not plug into the Arduino, but instead plug into the ground pin. If you don't remember what pins are what, remember that this, usually when you pull it out, the larger one is the ground one. And so that means that when you know which one is the ground, everything else is the color. And so when you have the ground one put in, it goes red, ground, green, blue. And so when you have the ground one plugged in, at least you remember which is what. So once you've got the ground pin plugged in, we're going to put our 330 ohm resistance. Now, the facing of the resistor doesn't matter. It's only the little rings on it that show what color they are. So, they show what resistance they are. We will plug them in to the pins. Now, we will bridge the gap between the break, and this will help with spacing. We don't have to bridge the gap on the break, but I like to because it makes it a lot more solid. Next, we'll put the colored wires on, starting with the red. They will plug in to the Arduino. Starting with red on pin 8, then green on pin 7, and then blue on pin 6, which is our last cord, the blue one. And now, we are done. It is entirely wired up, and we can test it now. The lights came on. And so now, look at that. That's the wrong color. Oh, interesting. Truly. That was very wrong color. That is so weird. All the other ones are right. So, weird. But now it works. And our colors are right. They don't show up right on the camera, but that might be just an issue with the camera. I don't know. Okay. But now we're done. It's built, put together, And we know it works. Starting with our low one to our high green. If you can hear it that well, but I can move it closer so you guys can hear it, but
Alright, well, now for the coding. So, to start, we are going to initialize our variables. And our variables are going to be integers, which are declared by putting int, and then the name of our variable. You're going to do this 4 times, one for the pin of the buzzer, and this will be on pin 5, another on the pin for the red of our LED, and that'll be on pin 8, another for the B, for the blue, on the LED as well, and another for the green. Now that we have that set, we are now going to create our functions just empty. So how do we declare a function is we put void before the function. For this function, for the code, we are going to be using the 3 functions setup, and we enter the function. We enter the function with curly brackets, and Arduino IDE, which is the program we're using, is going to autofill the end. Then we're going to create a function for our RGB LED. We're going to call it RGB handler. Then we are going to have another function, this is the last function, and this function is going to be our loop. This will happen forever until we stop the code. Which means as long as the Arduino is plugged in, it will continue to loop. So to start, we are going to initialize our pins and whether or not they're an output or input. So to start, we're going to do our outputs, and we declare this by doing pin mode, and then a little semicolon to show that that's the end of a line. And then what we'll do is we will put the P variable for the buzzer, and then we will declare it as output. And then we can copy this 3 more times to do the RGB for the LED, and then we will do our buttons as our input. We do the same pin mode, but this time, instead of putting a variable, we are going to put an A and then a 0 for the first pin on the buttons. These are our analog inputs. We can copy this. One more time. There we go. Then we will replace the number next to the A, ascending up to 5. So that's 0, 1, 2, 3, 4, and 5 analog input. Now, after we have that, we are going to create, let's create one more function, and this will be our button handler. And then we will start with the button handler, and we will create, I believe it's 7 if statements. So we will start with the regular if, and we'll put 2 brackets, 2 parentheses. Inside the parenthesis, we're going to put digital read with a capital R, then 2 parentheses again, and then inside of that we are going to put the pin analog 0 to show for the first button. Then we're going to do a space with 2 equal signs and then high. What this will do is we'll check if the button is being pressed. Then we will type else afterwards. And what we can do, press enter, hang on. We can select all of this, and we can copy this 6 times. 2, 3, 4, 5, 6, 7. Okay. So then, for this final one, wait. That's 1, 2, 3, 4, 5, 6. Yeah, okay. 7. Ending with an else statement at the very end. So, now, what we're going to do is, for the insides of these, we are going to put a tone function, and then we will put the pin for the buzzer. Then we will do the hertz values, which here, we go grab them real quick. There. So that way you can just copy and paste these down. And that'll be for our C5. And then we will do another, we're going to put 100 for our amount of milliseconds that this sound will last for. Now, milliseconds go in thousands, and so each 1,000 milliseconds is equal to a single second. So by putting 100 milliseconds, we are doing 1/10 of a second, essentially making the button only make a sound if it's being pressed. And when you let go, it won't continue the sound. What we can do now is copy this to all of these. And actually, we won't need this else statement. But we will for this RGB handler. So now we will copy all of these down to their respective little tones. And now we have our RGB. Now we have our button handler. We're going to work on our RGB handler. So, to start, we're going to start our first if statement. And this is going to be similar to what we've done for our button handler. So, we are going to do if the digital read of A0 equal to high, then we are going to do our curly brackets, then another else statement, and then we can copy this 5 more times. 5. Then we will do another curly bracket, press enter, and now we have our if statement fixed. So now we are going to do our RGB light functions. How we do this is we call analog write. And so then we put the pin that we want it to write to, which for this case, since we created variables for them up here, we will do R for our red. We'll set this to 255, or I guess 0 for now. Then we will copy this 2 more times, set this to be green, and set this to be blue. We are first going to copy this and put it down here in this else statement. The only reason that we're going to leave this all zeros in the final else statement is if we don't want any button to be pressed, then we don't want the light to be on. If all of these are checking if a button is being pressed. What we don't want is the light to stay on after the button is pressed. So what we'll do is we will go through and we will put the rest of the buttons on. A 1, 2, all the way ascending to 5. So now we will copy these all in, but we will change the values depending on the color of the button. So next, the first button is green. Then the next button is white. So we will set these all to be red, to be full. Then the next button is yellow. So we will set this R and G value to be 100%. Next, we will set the next one, which is red, to be full. Then we will set this last button, which is blue, and the last one to be green. Now, we have already called these down here. So whenever we run this code, whenever we upload the code, it should work perfect. Which if we check it real quick, that is weird. Oh, I see what the problem is. We did not change the buttons on the values here. We had to put those all from ascending to 5. My apologies. We're going to recompile the sketch and upload it. There. There we go. I just checked it and it works just fine.